visual script. Now I'm trying to introduce the visual script. This is the I/O table to describe the PLC input and the output. After the definition of the I/O table, we have to write down the scripts. After create, we feed in the scripts into the input script action specifications. In this table, we can see as input 21 be activated. The P1 KH0 script will be executed. Suppose I25 is 1, P1 KH180 will execute it. So the important is how to define and how to teach to get this scripts file. Let's see the first one, P1 KH0, and to teach more, we can load P1 KH0 into the data area. It's too small to see. We can use save CSV file to save it into an Excel file so we can see in ASCII format. Like this. This is P1 KH0 Microsoft Excel file. The first command is K21 S21. What it means? What is the definition of the script? We have to introduce the definition of the script command. This is the definition of the script. Before 14, K14, these instructions is numerical control commands. After 14, there are plenty of commands. K15 to K33 is I/O command. ADDA command. Direct object command. In our script files, you can see plenty of K6. K6 is the first point of the join more. And K10. K10 is the last point of the join more. The first and the last is important in our water jet control, because the first point will open the water and open the sand, open the pump. The K10s will close the water, close the pump. For example, the K6, for 3 axes, there's only x, z, y. In a dynamic, in the direct sy, it has the opposite position. For 4th axis, is defined as y, z, xi. For 6th axis, is defined as y, z, a, b, c. And for 8th axis is defined as y, z, a, b, c, s, y, z, u, v, w, a, b. This z height is defined the clear height. Suppose for the 2D horizontal cutting, on the top of the surface is 0, z 0. Suppose we defined in this column 10. That means the clear height is 10 millimeters above the cutting surface. This column is F. F means phi rate. Similar to GM code, FANUC GM code, K2 to K14, numeric control equal to FANUC G0, G1, G2, G3. In the feet, a little difference. In our definition, it's not millimeter per minute. We define the feet as millimeter per second. It's very important. The geometry, straight line, and arc. For the joint mole, we have the straight line. The K6 is the first point of the joint mole. How about the polygon? The second point we defined by K8 is joint mode, the second point. The last point of joint mode is K10. As to the arc or circle, the first point is K6 as well. But for the arc, the second point is K9. The last point is K11. In addition to the joint mode, we have a Cartesian coordinate system. The Cartesian coordinate system, the first point is K7. For the straight line, the second point is K2. The last point of straight line of Cartesian coordinate is K how much? Is K12. Now I try to introduce the arc definition of Cartesian coordinate. The first point is K7 as well. The second point of Cartesian coordinate is K3. The last of the Cartesian of arc is K13. Okay, after the definition of the numerical control, we try to introduce the I/O control. K20 is open I/O. The I/O has input and output. In the S column, K20 is to open and input I/O. If we feed in something in this Y column, that means output I/O is opened. Suppose for output Y3 is open water, then we fill in K23 in here. That means after these instructions, the Y3 open. A relay is opened to output the circuit to let the water pump actuated, and the water will flow out. The K21 is closed I/O. There are input and output as well. Suppose, for last example, we try to close the water, then we have to write down K21 and the 3 in here. After this command, the Y3 output, the water pump will shut down. K20, the delay time in second. In S column, you can fill in, suppose 1. That means delay 1 second. And we have a DAC output and the K24 ADC input as well. In our program, you will see K16. K16 is to let an object hidden or to show. The object number has to fit in this column. The object movement coordinate can be fit in S, Y, Z value. After this line executed, the object defined in here will move to XYZ position. And then we have to define K26. Object C move XYZ. The object number has to fit in here. The move to position fitting XYZ in here. K27 to specify the rotation of an object. The object is fitting the F column. Rotation center XYZ write down in these 3 columns. And the UVW fitting the rotation directions. We right now speak again about the K16. You see here, you can show an object as object. The object has to fit in these positions. Suppose for the window object 7, we write down here is 7. We write down object, you see S is object. We write down 7 in here. If this value, C value, is 0, then the window is hidden. We write down K16, 7 object. In this value is 0, that means this object is hidden. That means cannot be seen. Okay, let's go back the P1 KH0 to see how the program executed, how the script running. In first command, K21 is hidden the input 21. The program we have seen, the K21 is 1, the P1 KH0 executed. So after the execution, the first command, we have to cross 21. If 21 input not crossed, the program will execute it again and again. So after shut down 21 input, the second is 21K. That means shut down the output 6. What means the shut down the output 6? We can see the I/O table in our program. The output 6 is window up. That means as Y6 equal to 1, the window will up. As the window up, the input X19 will be 1. So as the shutdown, the window up, that means the window down. As the window down, the S20 window down sensor will become 1. So in here, 21 K21 shut down the output 6. That means the window will down. The window will down, then we can turn the C table. For the simulation, K26, the window is object 7. So we can see on the screen the window down is to lower the Z to minus 20 millimeter position. We already know as the window down, the X input 20 will be set 1. The table cannot be turned. After we can make sure the window is to the down limit position. The input 20 become 1. So in this line, we use K22 as 20. As the window down, the input 20 will become 1. After the 20 input become 1, so K2032 is fully satisfied. Will automatically to go down to this line. In this line, K22, waiting the output 13 become to 1. So what is the 13 means? In the I/O table, we can see the 13 is wrong lane. Its green light is on. The low lane is on, is green light. The wrong lane is on, is yellow light. The wrong lane, how to let the wrong lane become yellow? After we feed in the parts on the table, we have to push a cycle start button. After we push the cycle start button, the wrong lane will turning on. You can see the yellow light is on. As the moment the low lane, the green light will be off. In the same time, the photo sensor Y9 is on to protect the people into the fitting area again. So if we fix the clean parts in B axis and the step down, the yellow line Y13 should be 1. So after we wait the yellow line on, we go on to the next line. The next line is move the C table from 0 to 180 degrees positions. Use the 10 second per degree speed to turn the table to 180 degree positions. After this, after turning, the next program will be executed. How to let the next program executed? That means to water jet, cutting the parts. We see this line in advance. K2022. That means let input 22 become 1. As this input 22 become 1, the next program will be executed. Which program will be executed? 22 is P1 KH2 will be executed. The water jet will be operated to clean, to cut the parts. What the K20 and the 26 input become on means, in the program, if we turn on input 26 into 1, the PLC inside the program will turn off the yellow light and turn on the green light and turn off the light protections. As the green light is on, that means to tell the operator you can go in to step the foot button to lose the finished parts, if there is any finished parts, to take it off and to pick another part intended for operation and fix into the fixture at the step foot on button. So the input 26 is very important to turn off the yellow light and turn on the green light and turn off the light protection and to let the operator into the fixing position. Okay, let's see how P1 KH0 work. We go back to the program. To see the P1 KH0 works. The reason we say the visual script is the script can be seen on the screen visually. After the program be loaded, we can run to see the program executing. It's turning 180 degrees. First of all, it has to turn off input 21 and lower the window lowered, and the table is turning. After in position 180 degrees, the program will waiting the program will turn on 22. Turn 22, that means is to let the automation executed P1 KH2. Let's see the P1 KH2. The same we can renew to let this area be vacant, and the low P1 KH2 into here and save CSV file. Then we can see in ASCII P1 KH2. The first line is K20 22 to let input 22 become 0. Before water jet, we have to use K20 to let Y6 on. That means to let the window up. After the window up, the import 19 will become 1. The program can go through this line. So this K26 is to lay the object 7, that means the window, to the 0, 0 position, that means to the upper position. So after the window to the upper position and the response import 19 become 1, then started to use K6 to open the water and open the pump, and the water gun go to 20 minus 20 position and executed the circle until K11 shut down the water, shut down the pump, and the K11 arrived to X20 Y minus 20 position. In that moment, the table is in 180 degree position. So as the first circle in the Z equal to 0 position, the command K8 will lower the Z position to minus 200. Horizontal 0 to horizontal to minus Y minus 200 positions, and then lower the gun, water gun, to Z minus 20 position, and then from this column to this column to execute the water on, water off, and the circle executed one circle in at Z equal to minus 20 position. So after water gun off, pump off, the X go back to center 20, from 20 position to 0 position, and then from Z minus 20 up to Z 0, and then Ka, the Y from minus 20 200 go back to 0. So the home position is arrived. The table is still at 180 degree position. So the program finished. Then we use K20 and import 23 to become 1 to continue to execute the next program. As import 23 is on, the program will execute it P1 KH 180 BK a program. Okay, let's see the P1 KH2, the program running visually. The program in the data area already, we just simply run. You can see it goes here to run a circle first and move back to the center and lower 20 millimeter and to cut a round circle. After that, move to the center and lift to the Z 0 position and go back to the home positions, and activated the K21 input 21 become 1. You see 1 here. So we see the next program, the last program. The same, we renew it. And the low P1KH 180 BK program. The program in this data area, we can save CSV file. And to see the CSV file, P1 KH1 180 BK. The first command K21 23 become off 0. Then this is turning operation. We have to K21 Y6 off. Use this command. After the window down, the input 20 will become 1. The K23 will be satisfied and go down to the next step. The K26 in here is to show the picture object 7, the Z from 0 to -20, -200 positions. This is geometry variation. The program still cannot move further before we wait for light 13 turn yellow. Output 13 become 1, means the cycle start button is pressed. That means the component is renewed. So these conditions fully satisfied. We turn the table from 180 degrees to the 0 positions. And then we use K20, let the input 26 become 1 to turn off the yellow light, turn on the green light, turn off the light protections to tell the operator go into the fixed positions, to put off, to lose the finished parts, to put on a new parts on the fixture, and for on step. And after this operation, and go out to press the cycle start to go on the next circulation. So after this command, we use the K20 to let 26 input become 1 to continue to execute next program. Okay, let's go back the program to see how the P1 KH 180 BK program going. This is turning table. Let's run. The window down, right? And the table turning to go back to 0 orientation positions. Okay, then we see 26 P1 KH1. The same, we renew the data in this area and pick P1 KH1. P1 KH1. And to use save CSV to create Excel file. so we can see this program more accurate, more clear. P1 KH1. The first command is K21 X24 to let input 24 become 0. This is water jet operation. So we have to K20 let Y6 become 1. That means to upper the window, the object 7 to 0 positions, to up positions. As the window up, the input 19 will become 1. So K22, you will see the input 19 become 1. The program can be automatically lower one line. The K6 is water jet open until one circle finished. K11, the water jet off. The first circle is operated at the Z equal to 0 position. And then we use K8 to move the gun to the center as X equal to 0. And then lower the Z to minus 20 for the next operation. K9, K6, water gun on until K11, water gun off. The circle is operating at Z equal to minus 20 position. And then we use K8 to let the water gun move from X20 to X equal to 0 position. And then move the water gun from Z at a lower position minus 20 to the up position Z 0. And then let the gun from Y minus 200 go back to Y 0. That means to home position. After home position, we use K20 to let input 25 turn on, become 1. 25 become 1. Then we can execute the last program, P1 KH180. If we want to circulate the program, then we have to put on K20 in X position 22. So we can go back to P1 KH2 and then circulations operation. So this is fundamental and very simple circulations control example. Now I try to let the PLC mode running for demonstrations. How to let the visual script running automation? We have to use the PLC mode. Turn on the PLC mode, you will see something different down here. The program should not run, but because we just let 24 become on. So the program executed. We can use reset to let everything to the original positions. Then purely demonstrate the PLC mode turn on and how to start it. Let I input 21 become 1. We will start it from the very beginning and on until the end. Okay, 21. So let me execute it. The input 21 become 1. The program is running.
Chiao.